Kubernetes and GKE Part 27. This episode has 5 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. What are resource limits? Here's a strong way to approach it. Resource limits in Kubernetes define the maximum amount of CPU and memory a container is allowed to use. Core idea: a resource limit is a hard cap on how much CPU or memory a container can consume. If a container exceeds its limit, CPU it gets throttled, memory it may be terminated, killed. Why resource limits are used: they help to prevent a single container from consuming all node resources, ensure fairness between workloads, improve cluster stability, protect critical applications from noisy neighbors. How it works: 1. You define CPU or memory limits in pod spec. 2. Kubernetes enforces these at runtime. 3. Container usage is restricted based on limits. Example: YAML version v1 kind. Pod metadata: name, my app spec, containers, name, app. The exact commands and code are in the written question bank. Nice. Let's continue. Question 2. Explain COS classes. Here's a strong way to approach it. In Kubernetes, COS, quality of service, classes define how pods are prioritized for resource allocation and eviction under pressure based on their CPU and memory requests and limits. Core idea: COS class determines how important a pod is when the node runs out of resources. Kubernetes uses COS to decide which pods get killed first during memory pressure. How stable resource guarantees are for a pod. Why COS classes matter: they help Kubernetes manage resource contention, decide eviction order during node pressure, ensure critical workloads stay alive, improve cluster stability. The 3 COS classes. 1. Guaranteed. Highest priority: a pod is guaranteed when CPU request equals CPU limit, memory request equals memory limit. All containers define both. Example: resources, requests. The exact commands and code are in the written question bank. Great. Moving on. Question 3. What is eviction? Here's a strong way to approach it. In Kubernetes, eviction is the process of removing pods from a node when the node is under resource pressure or administrative action, so that the cluster remains healthy and stable. Core idea: eviction equals Kubernetes forcefully removing a pod to free up resources or maintain node stability. Why eviction happens: Kubernetes evicts pods when a node is facing issues like 1. Resource pressure, memory pressure, most common, disk pressure, CPU contention, indirectly. 2. Node maintenance, kubectl drain operation, cluster upgrades, node scaling down, cluster autoscaler. 3. Policy-based eviction, pod disruption budget, PDB, restrictions, system priority decisions. How eviction works: 1. Kubelet monitors node health. 2. Detects resource pressure. 3. Selects pods based on priority, COS, PDB, priority class. 4. Sends eviction request. 5. Pod is gracefully terminated, if possible. 6. Controller, deployment or replica set, recreates pod elsewhere. Eviction flow: node pressure, kubelet select pod, evict pod, scheduler places new pod. Eviction versus deletion feature: eviction deletion initiated by kubelet or system user or API purpose. Resource management manual removal behavior reschedules pod may or may not reschedule. Awareness of PDB: yes no priority order of eviction when resources are low. Kubernetes evicts in this order: best effort, burstable, guaranteed, from least important to most important pods. Role of pod disruption budget, PDB before eviction. Kubernetes checks PDB rules if violating min available or max unavailable. Eviction is blocked. Example scenario: node memory is full, system needs to free space. Kubernetes will 1. Evict best effort pods first. 2. Then burstable pods. 3. Avoid guaranteed pods unless necessary. Simple analogy: think of a train. Train equals node, passengers equals pods. Eviction equals removing passengers when train is overcrowded. VIP passengers, guaranteed COS, are removed last, or not at all. Types of eviction: 1. Soft eviction, graceful shutdown, SIGTERM sent, grace period allowed. 2. Hard eviction, immediate removal, rare, SIGKILL after timeout. Common tools triggering eviction: kubelet, resource pressure, cluster autoscaler, scale down nodes, kubectl drain, maintenance. PDB controller, protects from too many evictions. Best practices: always set resource requests and limits. Use PDB for critical apps. Avoid best effort in production. Monitor node memory or disk pressure. Interview ready. Definition: eviction in Kubernetes is the controlled removal of pods from a node triggered by resource pressure or maintenance operations, where kubelet selects pods based on priority, cost class, and pod disruption budgets to maintain node stability and ensure efficient resource utilization. Alright, next question. Question 4. Explain node selectors. Here's a strong way to approach it. In Kubernetes, node selectors are a simple scheduling mechanism that forces a pod to run only on nodes with specific labels. Core idea: node selector tells Kubernetes, run this pod only on nodes that match these labels. It is the most basic way to control where pods are scheduled. Why node selectors are used: they help to place workloads on specific hardware, GPU, SSD, high memory nodes, separate workloads, dev versus prod nodes, control cost, use cheaper nodes for batch jobs, improve performance by targeting suitable nodes. How it works: 1. You label nodes with key value pairs. 2. You define a node selector in pod spec. 3. Scheduler only places pod on matching nodes. Step 1. Label a node kubectl. Label nodes. Node 1 disk type equals SSD. Step 2. Use node selector in pod API version, v1 kind, pod metadata, name, my app spec, containers, name, app. The exact commands and code are in the written question bank. Let's keep going. Question 5. What is cordon and drain? Here's a strong way to approach it. In Kubernetes, cordon and drain are node management operations used to safely control workload placement during maintenance, upgrades, or troubleshooting. Yellow circle 1. Cordon. Core idea: cordon marks a node as unschedulable, meaning no new pods can be placed on it. Existing pods are not affected. What happens in cordon: node is tainted as unschedulable. Scheduler stops placing new pods on it. Existing pods continue running normally. Command kubectl cordon node 1. Use cases: preparing node for maintenance, preventing new workloads on a problematic node, controlling workload distribution. Simple analogy: think of a bus. Cordon equals no new passengers allowed to board. Existing passengers stay seated. Red circle 2. Drain. Core idea: drain safely evicts all pods from a node and makes it empty for maintenance. Unlike cordon, it removes running workloads. What happens in drain? 1. Marks node unschedulable. Like cordon. 2. Evicts all pods, except daemon sets and some system pods. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.